Okay. So so in this question, we're going to solve the question number 5. So the question is, a farmer who sells at a fixed price of $5 per unit and has the cost function C is equal to 3.5 plus 0.5 Q square, plants to maximize profit under certainty. After planting, she discovers that she discovers she can have a fertilizer applied that will increase her yield 40% with a probability of 0.25, 60% with a probability of 0.5, 60% with 0.5, and 88% with probability of 0. With probability of 0.25. Now, her utility function is U is equal to root over of pi. Okay. Now the question is, determine the maximum amount that she is willing to pay for the fertilizer application. Now we have, this is a given conditions. Now the question is that determine the maximum amount that she is willing to pay for the fertilizer application. Okay. Now contrast this amount with the expected value of the increase in her profit as a result of fertilizer application. Contrast this amount with the expected value of the increase in her profit as a result of fertilizer application. Okay, so this is the entire question. Okay, they have given all the conditions and they have asked that we have to determine the maximum amount that she is willing to pay for fertilizer application. Now let's solve it. Okay, now we know that to maximize profit, the farmer needs to determine the quantity that she should produce and sell, right? So to max profit, farmer needs to determine farmer needs to determine the quantity that she should produce and sell. Okay. Now let Q be the quantity that produces and sells. Let Q be the quantity. Okay. And P be the price. And P be the price per unit. Okay. Since she sells at a fixed price of $5 per unit. So P is equal to 5 and her revenue R will be PQ. So she sells at a fixed cost $5 per unit. Okay. That is P, and P, that is P is equal to 5. Then revenue is equal to P into Q. Okay. Thus, her profit will be given by pi is equal to R minus TC, that is nothing but PQ minus CQ. Okay. So if we simplify this, we will find P minus C into Q and just put the values of this of P and C. You will find that 5 minus 3.5 minus 0.5 Q square into Q is equal to 1.5 minus 0.5 Q square into Q. So you'll get the value that is 1.5 Q minus 0.5 QQ. Okay. Now to find the profit maximizing quantity, that is assume that Q star, we take the derivative of pi with respect to Q and we have to set it equal to 0. That is the normal method of optimization. So to find profit max quantity Q star, we have to find d pi dq, right? So it will be d pi dq, it is equivalent to 1.5 minus 1.5 Q square is equal to 0. So from that value, you will get the optimum value Q star is equal to 1. Therefore, the profit maximizing quantity is Q star is equal to 1, and the corresponding profit will be, if you just put the value of optimum quantity in the equation you will get the optimum profit value. Value of profit will be price star is equal to 1. So let's put the value. So therefore, profit maximizing quantity Q star is equal to 1, and therefore optimum profit pi star is equal to 1.5 minus 0.5 into 1 cube, that is equivalent to 1. So now we need to consider the effect of the fertilizer application on farmer's yield, right? So just a second. Now we have to consider the effect of fertilizer application. The effect of the fertilizer application on the farmer's yield. Okay. So suppose let Y be the new yield without fertilizer. So Let y be the new yield without fertilizer, and y prime be the yield with fertilizer, and y prime be the yield with fertilizer. Okay. Now our yield will be, therefore y prime will be equivalent to k into y. Okay. And we have assumed that k is the increase in yield as a percentage. Okay. Now we are given that the probabilities of increase in yield, therefore it is given that uh, the probabilities are for given probabilities are 40%, 60%, and 88%. So that means they are 0.25, 0.5, 0.25. Okay. Thus, we have to find out the expected value of this k. So, thus the expected value of k is E of k is equal to 0.25 into 1.4 plus 0.5 into 1.6 plus 0.25 into 1.88. So if you solve this problem, you will get the value is equivalent to 1.6. Therefore, if the farmer applies fertilizer, her expected yield would be y prime is equal to suppose ky, that means 1.6 into y. So you can conclude that if the farmer applies fertilizer, her expected yield will be y prime is equal. Now, next we need to find the maximum amount that the farmer is willing to pay for the fertilizer application. Okay. So this next part is we need to, just a second. Now we need to find the maximum amount that the farmer is willing to pay for the fertilizer application. Okay. So what can we do? We can do this by determining the maximum amount that the farmer is willing to pay for a 60% increase in yield, since this is the most likely outcome. Now, suppose let P be the price that the farmer is willing to pay for her fertilizer application. That is the willing to pay price. Okay. And let delta pi be the increase in profit. We know that. So we write this pi. So this is nothing but the increase in profit, okay, or the change in profit, whatever you can say. Um, a result for the fertilizer application. So if we just construct these, we can write it as delta pi is equal to 5 minus 3.5 minus 0.5 y square into y prime minus 5 minus 3.5 minus 0.5 y square into y. That means delta pi is equal to 1.5 y prime minus 0.5 y cube minus 1.5 y plus 0.5 y cube minus 1.5 y minus 0.5 y cube. Okay. So if you just rearrange this, delta pi is equal to 0.5 y cube minus y prime cube minus y cube plus 1.5 into y prime minus y. That means delta pi is equal to 0.5 into 1.6 y whole cube minus y cube. Okay, plus 1.5 into 1.6 y minus y is equivalent to delta pi is equal to 2.55, or you can write 2.56 y square plus 0.9 y. Okay, so this is the value. So the farmer's utility function is the farmer's utility function is u is equal to root over of pi. Okay, so we can assume that the farmer is risk neutral. This is a very normal assumption from we can derive from this equation. So the farmer is risk neutral since she is willing to maximize her expected profit. Therefore the maximum amount that the farmer, so why she is risk neutral? Because she is willing to maximize her expected profit. Therefore the maximum amount the farmer is willing to pay, you can write for the fertilizer application, you can construct it as P is equal to E of delta pi minus integration of delta pi du. Okay, so this is the equation and this is the solution. Okay, thank you.